So this is our first day of starting to review for the Regents in January. What we will do to begin is do some mini units that reviews the material from last year. So the sub should be passing out to you, or you may already have it, the Unit 1 from last year review packet. It only has a couple of days in the mini unit, so only 2 days. So our homework for tonight is going to be packet page 7, and we're going to go through some problems, and I'll highlight when we see problems that are fairly similar to some of the homework ones, so you'll know where to flip it back to. So just general slope-intercept form of a line. We're going to get to that eventually on one of the slides, so I'm actually going to skip over this warm-up. We will need our calculators out today, so if you could be taking those out now. And if you need a calculator, just ask the sub to get you one. They're in my top left drawer in my desk, and just make sure to return that at the end of the period. So we're going to go a little bit out of order to try and focus first on the ones that people tend to have more difficulty with. So we're going to start on the bottom of page 3, where it says domain and range. So domain is just any of the x's that work, and the range is any of the y's that work. Now, if something's going to be a function, each x should have only one y value with it. And we often check if something's a function with the vertical line test. So if you flip to the next page, we have a couple of functions, and imagine we had a vertical line. So you can hold your pencil as a vertical line. If you drag it over that function, as long as at no time does it hit the graph twice, then that means it will be a function. So this one, the first one here, this one would be yes, because it does pass the vertical line test. But the one on the right, notice in some locations, we are hitting twice. So that one would not be a function. We are going to skip the bottom of page 4, and we're going to spend some time on page 5. So the x's that work in a function are basically the x's that do not give us problems. We see listed there where it says a and b, the two main problems we see with functions when trying to figure out the domain. If you have a square root, we cannot have a negative under the square root because that would give us an imaginary number. Also, we can't divide by 0 because that would give us an undefined. So if you have square roots, or if you have dividing by 0, we need to be careful, and we do what's called restricting the domain. Anything else, if it doesn't have those two things, then our domain tends to be all real numbers. You may recognize that phrase from last year. So all real numbers, and the fancy symbol for it is a capital R, but that has double vertical lines. So what we're going to do is we're going to see if we can figure out our domain. We're going to graph it, and then we'll figure out our range. So in this one, for the domain, we have a square root. So a square root, you cannot have negatives underneath. So because we can't have negatives underneath, that means we can only have positives or 0. So you're always just going to take your stuff that's under the square root, and you're going to make it greater than or equal to 0. Now in this case, x is already by itself, so that's just our domain. Hypothetically, if we had had like x minus 7 greater than or equal to 0, we would have added the 7 over to get x greater than or equal to 7 for our domain. But because x is already by itself, in this case, our domain is just already done. So what we're going to do now is we are going to graph this on a graphs page. So see if you can go ahead and do that. And when we graph it, we want to plot actual points. So meaning we should be putting tick marks and everything. So on my graphs page, I've got my square root of x. I'm going to go Control T, and we're just going to pick the points that are nice numbers. So the first one we have is 0, 0. So let's go ahead on our graph. We'll put some actual tick marks down. So we've got 0, 0 as a point. Next nice point we have is 1, 1, and after that we have is 4, 2. So we'll plot 1, 1. So that's going 1 to the right and 1 up. 4, 2, we'll go 4 to the right and 2 up. And we'll maybe go one more nice point. If we go down, we get 9, 3. Now it's not wrong to plot the other points too, but we can get the sense of the function from just this. Now, if you notice in your picture of the graph, it doesn't go anywhere to the left of 0, 0. And that's consistent with our domain that x was supposed to be greater than or equal to 0. So we're going to draw that in with a nice smooth curve, and then we're going to put an arrow on the right side because the graph does keep going that way. So now to do our range, range is the y values. So we want to think, what's the lowest y value? Well, the furthest down this graph goes is a y value of 0. And then we want to think, what is the highest y value? This graph keeps going up forever. So there is no highest y value. So if we want to say that the y's lowest is 0 and it goes up forever, our range will just be y is greater than or equal to 0. And it's greater than or equal to because we do have a point at y equals 0. In our next one, we do not have any square roots. We do not have any fractions whose denominator could be 0. So our domain is going to be all real numbers. So I'm going to write our fancy symbol, but if you want to just write out all real numbers, you can for that as well. And let's have you do Control Doc and add a new graphs page. Let's put this equation into the graphs page. And then you can do a Control T and pick out some points to plot. When you plot them, okay, put your actual scale on there, put your tick marks so you're plotting the actual points. Okay, we don't want just a rough sketch, we want actual points plotted. So I'm doing Control Doc to add a graphs page. Our equation we had was 3x minus 4. And then I'm going Control T. So some points we have are like -1, -7, 0, -4, 1, -1, and so on. If you plotted other ones, that's okay too. So maybe I'll go one more. I think 2, 2 was a point on there as well. So then I'll draw it in. This one was a line, and our domain was all real numbers, so we'll put arrows on both ends so it goes left and right forever. So now for our range, range is y's. We got to think, what's the lowest y, what's the highest y? Well, our lowest y is it goes down forever, and our highest y is it goes up forever. So if it's going up and down forever in each direction, our range is also just all real numbers. I'm going to use the symbol, but if you want to write out all real numbers, that is fine as well. Down on the bottom, we're going to do the same idea. So we're going to start by finding the domain. We have a fraction here, so we have to be cautious of the fraction. We need to make sure whatever makes the denominator 0 cannot be in our domain. So what we'll do is we'll take our x plus 2 and set it equal to 0. And we got x equals negative 2. That is the number we need to avoid in this function because it makes our fraction undefined. So for our domain, every x value is okay except for that negative 2. So the way we would write that is we would write our all real numbers, and then we would just say x cannot equal negative 2. Again, if you want to write out in words all real numbers, that's perfectly fine. So we're going to graph this now, and then we'll find the range. So we're going to add a new graphs page by doing Control Doc. I'm going to use my fraction template by doing Control Divide and put in the 1 over x plus 2 and hit Enter. So just notice roughly what our graph looks like. There is an asymptote there at negative 2, meaning it gets close to it but never hits it. There's also an asymptote at y equals 0, which is where the x-axis is. So if we do a Control T to get some points, we're not going to see too many points that are very nice. Let's get a few to the right of the asymptote and a few to the left. Well, notice here's our asymptote. A couple to the left we could do are negative 5, negative 0.3, negative 4, negative 0.5, and negative 3, negative 1. So I'm going to go ahead and plot those ones first. So negative 5, 0.3 is like a third, negative 4, negative a half, and then we've got the negative 3, negative 1. Now, I'm going to put in a dotted line at x equals 2 where that asymptote is. Sometimes you will see asymptotes represented with a dotted line. They don't show up like that on the calculator, but it helps us just guide our graph. So then we just curve it towards the asymptote and curve it towards the x-axis. If we go to the right of the asymptote, negative 1, 1, 0.5, and 1, positive 0.3. So we'll go ahead and plot those. So we've got negative 1, 1, 0.5, and 1.3. And we'll curve that in. So to do our range now, notice our graph goes down forever. Notice our graph goes up forever. But we do have one issue in the middle. The graph never hits y equals 0. So our range for this is going to be all real numbers, but y cannot equal 0. Our last one of these, we do not have any square roots. We do not have any fractions whose denominators we have to worry about. So our domain is just all real numbers. Let's do Control Doc and add a graphs page, and we'll put that equation in. Now notice this is a parabola. When we go to the table, we want to make sure we get some points on either side of that vertex. So just eyeballing it, it looks like the vertex is at x equals negative 2. So we'll pick some points on either side of x equals 2. So notice here is x equals 2, and notice how it's symmetrical there above it and below it. So we'll maybe use those points. So we're going to have 0, 3, and 1, 0 to start out. So here's 0, 3, here's 1, 0. We also had 2, negative 1. Then we're back to 3, 0, and 4, 3. And then we'll sketch that in with a nice smooth curve. Now for our range, we need to know how low we go. It's going down to -1. We need to know how far up we go. And notice it's going up forever. So we need to say with an inequality that we go as low as -1 and up forever. So we'll have y is greater than or equal to -1. It's got the equal to because it includes that -1. So on questions 3 and 4 of the homework, you're going to be doing something like this. Make sure to tell your domain and your range, and you've got to plot actual points. You can't just do a rough sketch. So just a little summary. If you have square root and there's some stuff underneath the square root, this is for your domains, I should say. To find your domain, start by making your stuff greater than or equal to 0, and then solve for x. If you have stuff in a denominator, set that stuff equal to 0, solve, and then eventually your domain is going to be all real numbers. X cannot equal whatever you get when you solve for that stuff. So that's like the one we just did in question 3 there. And then the last scenario is, what if you have a square root in a denominator? Well, you don't want your stuff to be negative. You also don't want it to be 0. So you would take your stuff and you would make it just greater than 0, because that avoids the 0 and keeps it positive. And then you would just work to get x by itself, and that would give you your domain. So those are the 3 special cases for domains that you need to be looking out for. And again, 3 and 4 on the homework will be like we just did on this page. All right, so topic 2 that we're going to look at for today is going to be over on page 6, and it is compositions of functions, and then also operations on functions. So up at the top, they define 2 functions for us, x squared plus 2x and x minus 4. So it's saying we want to take g of x and we want it to be squared. So we're going to take our entire x minus 4, which is g of x, and we're going to square it. And then it's saying we want to do minus f of x. So we're going to do minus, and then we need to make sure we subtract the entire f of x. So we're going to put f of x in parentheses. And for this question, that's as far as we're going to go. If it was a multiple choice, maybe we'd have to neaten it up some. But because this is not a multiple choice, it's a free response, we're just going to leave it right like that. All right, next we're going to work with compositions of functions. Compositions of functions are when one function's value is subbed into another function. It could be notated by the 2 things there that are in reddish pink. So this first one we read as f of g of x. So you find your value of g of x, and then it gets subbed into f's equation. You can also see it with an open circle. We always work with these right to left. So g of x should then be followed by f. So we're going to add in your packets, we're going to do both g of f of x and f of g of x for this first example. So g of f of x means anywhere there's an x in g's equation, we're going to replace it with f of x. So in this top one, and again, if you could please write in g of f of x like it is right here, we're going to take the f of x function and sub it in for x in the other equation. So we're going to have in parentheses 2x plus 1, and it'll all be squared. So that's what's represented by g of f of x. For the other one, f of g of x, we're going to do the reverse. So we're going to now take our g of x function, and that's what's going to get subbed into the other one. So we're going to have 2, and instead of the 2 multiplying an x, the x is going to be removed and replaced with an x squared. So we'll have 2x squared plus 1. So question 2 on the homework should be very similar to that. Down on the bottom, we're going to see it with some actual numbers. So what this means is we're going to start on the inside, we're going to do g of 5. And then once we have g of 5, that's going to tell us what gets subbed into f. So for starters, we'll do g of 5. This means anywhere you see an x in g's equation, we'll replace it with a 5. So we're going to have 5 squared. 5 times 5 is just 25. So now our original problem, instead of being f of g of 5, it's going to be f, and we now know g of 5 is 25. So we're just going to do f of 25. So now anywhere we see an x in f's equation, we'll just sub in a 25, and that'll give us 51. Moving down to the bottom one, you can actually sub a function into itself, and that's what we're doing here. We're doing g of negative 3. So start with the inside. We're going to do g of negative 3. This means in g's equation, anywhere you see an x, we're going to replace it with negative 3. When something's being squared, it's important to put what you're subbing in parentheses. If we square negative 3, that means negative 3 times negative 3, which is a positive 9. So now, in our original expression, we're going to replace the g of negative 3 with a positive 9. So now we're doing g of 9. So this means we are going to sub into g's equation a positive 9. So now we'll just do 9 squared, which 9 times 9 just gives us 81. So we're going to now jump back to page 1, and our third and final topic we're going to work with today is lines. So there's two forms of an equation of a line. The first is slope-intercept form, which probably you've worked with since middle school. So that's our y equals mx plus b, where m is our slope, which is the change in y over change in x, and b is the y-intercept, which is where the graph crosses the y-axis. The other one is point-slope form. Point-slope form just comes from cross-multiplying the slope equation of slope equals y2 minus y1 over x2 minus x1. There's two special cases for equations of lines, and that's when you have a vertical line and a horizontal line. Vertical lines will always be x equals some number. So let's say we had this vertical line in purple. Some points on this vertical purple line are 3, 0, 3, 1, 3, 2, and so on. Here's 3, 0, maybe 3, 1 is there, 3, 2. Notice they all have in common that the x value is 3. So the equation of this purple line would just be x equals 3. So notice it meets that format, x equals some number. If you had a horizontal line, it'll always be y equals some number. So let's say I put a horizontal line down here at negative 2. Some points on that line would be 0, negative 2, 1, negative 2, 2, negative 2, and so on. Notice the y value is always negative 2, which is why this red line's equation would just be y equals negative 2. So those are the special cases for equations of lines. Two special types of lines are parallel and perpendicular. Parallel lines have slopes that are equal, but their y-intercepts should be different, because if they're the same, then it would just be the same line. And perpendicular lines have slopes who are negative reciprocals. That means the sign is changed in the slope and the fraction is flipped. To be perpendicular means that they are forming a right angle when they cross. We are going to jump down to the very bottom of page 2, and we're going to do the last example there, which will be similar to homework question 1. We're going to write the equation of the line that passes through these 2 points. And we're going to eventually get it in the form y equals mx plus b. So we need to start by finding the slope. Our general slope equation is y2 minus y1 over x2 minus x1, often referred to as the change in y over the change in x. It does not matter which y value you start with, but whichever y value you start with, you must start with its x in the denominator. So of our two y values, I'm going to go ahead and start with y equals 3, this one here. So then I'm going to do minus the other y value, which is negative 2. Because I started with 3 in the numerator for the y's, I have to start with its x in the denominator, which is negative 1, and then minus our other x value, which is 5. When putting this in a calculator, I would suggest to use your fraction template. I'm going to go ahead and add a calculator page by doing Control Doc. So I'll do Control Divide now to get our fraction template. I'll put in 3 minus a negative 2. Now minus a minus is a plus, so if you just wanted to directly do that as 3 plus 2, that's fine as well. And then the denominator we have negative 1, and then we have minus 5. Let the calculator take care of simplifying it, and we get negative 5, 6. So we're going to take our y equals mx plus b, and we're going to fill in the m that we know, the negative 5, 6. From here, we can pick either of the 2 points to stub in for x and y. I'm going to go with the 5, negative 2. So there's our x, there's our y. So in place of y, I'm going to fill in negative 2. And in place of x, I'm going to fill in 5. So on the left, we'll have negative 2. Take a moment in your calculators and see if you can multiply the negative 5, 6 times the 5. So we should get for that negative 25, 6 plus b. Now we're just going to work to get b by itself. So we've got a negative 25, 6, so that'll have to be added to the other side. So now to find b, you're just going to add your negative 2 and 25, 6. So take a moment to do that in the calculator. And we should get 13, 6 for that. So we'll put it all together now. Just in that red equation, we'll have filled in now the m and the b. So negative 5, 6x plus 13, 6. And that is our equation that will pass through both of those 2 points that were given to us. Again, number 1 on the homework should be very similar to that. That's where we'll stop in this video. Any time left in the period, you can work on your homework, that page 7. And have a good rest of your day.